Hey everyone, ready for another deep dive? Today we're tackling zero-knowledge technology.
Ooh, that's a good one.
Yeah, it's really cool stuff. Specifically, how it's going to revolutionize blockchains.
Right, like how ZK rollups are changing the game.
Exactly. We're talking near-instant transactions, verifiable trust, the whole shebang.
I'm excited to get into it.
Me too. Our main source for this deep dive is a podcast interview with Uma Roy.
Oh yeah, CEO of Succinct.
You know it. They're the folks behind that ZK virtual machine called sp1.
That's right, sp1.
So to kick things off, what's the deal with this zero-knowledge tech?
Well, think of it like this. You can prove something is true
Okay.
without revealing the underlying data, like showing you the answer to a calculation,
I see.
but not the numbers or the formula used.
So like a magic trick, but for the digital world.
Exactly.
That's pretty wild, especially for blockchain where everything's supposed to be transparent.
Yeah, but the cool thing is it actually enhances transparency in a way.
You're going to have to explain that one.
Okay, so Roy talks about this concept of a ZK Lite client.
What's that all about?
So basically, it's a protocol that lets you check a blockchain's consensus,
Okay.
but you don't have to process all the data yourself.
So how does that work?
It's kind of like trusting a restaurant's health inspection score.
Instead of inspecting the entire kitchen yourself.
Exactly. You still get confidence in the outcome without all the work.
I'm starting to see how this could be useful.
Right. And when it comes to blockchain bridges, this is a game changer.
Bridges, meaning moving assets between different blockchains.
Yep. And right now, they're super slow and expensive.
Because you transfer so much data.
Exactly. But with a ZK Lite client, you could potentially prove the state of one chain to another.
Gotcha, using a ZK proof instead of all that data.
Much smaller, much faster to verify. Boom, problem solved.
That's pretty slick. But Roy also made this prediction that really blew my mind.
Let me guess, all rollups will become ZK rollups.
You read my mind, even the ones that are currently optimistic.
Yep, that's a bold claim.
So what's the difference between these two approaches, and why ZK might be the endgame?
All right, so both optimistic and ZK rollups are ways to scale blockchain transactions.
Okay, but they go about it differently.
Right, optimistic rollups assume all transactions are valid.
Unless someone challenges them.
Exactly, which is why they're faster at first.
But then withdrawals can get held up because of the challenge period.
Exactly, whereas with ZK rollups,
You're using ZK proofs to confirm the validity of those transactions up front.
right from the get-go, so withdrawals are much faster.
And arguably more secure since you're not relying on someone to spot fraud.
You got it.
Now, Roy mentioned Succinct actually converted an optimistic rollup, OP stack, to a ZK rollup.
Oh yeah, using their P1 technology, they call it OpSync.
OpSync, all right, but how is that even possible? It's like transforming a car into a plane mid-flight.
Well, the key is proving the execution of the rollups code
Okay.
with a ZK proof. So instead of re-executing every single transaction on the main chain,
To make sure they're all good.
you just verify this tiny little ZK proof.
Which basically says, hey, all these transactions were processed correctly, trust me.
More like trust the math.
Right, and since these proofs are so compact and easy to verify, you get all the ZK rollup benefits.
Without having to rebuild the whole system from scratch.
That's some serious wizardry.
Yeah.
But speaking of magic, isn't writing code for these proofs incredibly complex?
Oh yeah, historically it's been a nightmare.
Roy compared it to writing an assembly language, like breaking down computations into basic additions and multiplications.
It's super low-level stuff.
So why was it so challenging?
Well, the cryptography behind it all relied heavily on polynomial equations.
Okay.
And additions and multiplications are the simplest operations to represent with polynomials.
So it's like trying to paint a masterpiece using only straight lines.
Right. Possible, but extremely tedious and complicated.
And that's where Succinct's sp1 comes in to save the day.
You know it. With sp1, you can write code in Rust.
Which is a much more developer-friendly language.
Way more common in blockchain development, too.
And sp1 translates that into something that can actually be proven.
Exactly. They do this by proving the execution of something called RISC-V instructions.
RISC-V instructions, what are those?
They're a type of instruction set architecture.
Okay.
Kind of like how Ethereum's EVM works.
What's a low-level language that computers can understand?
Yeah, and by proving those instructions were executed correctly.
sp1 can prove the entire program ran correctly.
It's a huge breakthrough because it makes ZK development accessible to way more developers.
You don't need to be a cryptography genius to build verifiable systems anymore.
That's the goal.
Love it. So it's like building a bridge between human-readable code and the complex world of ZK proofs.
A bridge built with Rust and powered by math.
And Roy mentioned that sp1's performance can sometimes even beat custom-built solutions.
That's right. It's pretty impressive.
How's that possible?
Yeah.
Did older ZK rollups just have bad code?
No, not necessarily bad code, just that technology moves fast.
Things get outdated quickly.
Exactly. ZK tech has advanced a lot since the first ZK rollups were built.
sp1 was designed for speed, especially with its GPU implementation.
GPUs are way better for the parallel processing that ZK proofs require.
Like having the right tool for the job.
Definitely.
And Roy made a great point that even if sp1 isn't always the absolute most efficient,
The benefits might still outweigh the costs.
they highlighted code reusability, easier updates, and a better developer experience.
Those are huge advantages in the long run.
Makes sense. It's like that trend of increasing abstraction in software development.
You make things easier to use so more people can build amazing things.
And in this case, more developers can build verifiable systems.
Exactly. And that leads to more innovation and accessibility in the whole ZK space.
Okay, so we've got this powerful ZK virtual machine.
Yeah, it's pretty cool.
But crunching all those computations still takes a lot of power, right?
It's a computationally intensive process for sure.
Which brings us to the Prover network.
Ah, yes, a decentralized network of GPUs all working together.
Generating ZK proofs for anyone who needs them, it's like Bitcoin mining, but for proofs instead of blocks.
Exactly. It's a fascinating concept.
So how does this Prover network actually work? And how does Succinct keep it truly decentralized?
Well, anyone with a GPU can join the network,
Okay,
and they can earn fees by generating these ZK proofs.
so there's an incentive to participate,
Right. When someone needs a proof, they submit a request.
and the provers compete to generate it.
Exactly. And to prevent any one prover from getting too much power.
Succinct uses an auction-based allocation system.
So it's all about supply and demand, like a marketplace for proofs.
That's really clever. But here's the question that's been bugging me. If this network is decentralized,
Yeah.
how does Succinct make money?
They plan to take a small marketplace fee.
For facilitating the interaction between proof requesters and provers.
Kind of like how platforms like Uniswap take a cut of each transaction.
So it's a sustainable business model while keeping things decentralized.
That's the idea.
Awesome. And Roy was clear that ZK isn't just about rollups.
Oh no, it goes way beyond that.
They mentioned Celestia and Avail bridges, Bitcoin rollups.
Even zero-knowledge email and a driver's license verification app.
That's a wild range of applications. What's the common thread?
It all comes down to verifiable computation.
Which can be applied to any system that relies on trust or transparency.
Exactly.
It's like a universal trust machine. The possibilities seem endless.
We're just scratching the surface of what ZK can do.
This is all incredibly exciting, but I think we need a moment to process all this information.
It's a lot to take in.
We'll be back in a flash to explore even more of ZK's groundbreaking potential. Don't go anywhere.
See you soon.
And we're back, ready to dive even deeper into the ZK rabbit hole.
I'm ready if you are.
So, we were talking about how ZK can make blockchains more efficient.
Yeah.
But it's really about so much more than that, right?
Oh, absolutely. It's like rethinking how we approach trust in any system.
Right. Like even with decentralized ledgers, we still have these points of centralization.
Exactly, like Oracle data.
Bridging between chains.
Even just running full nodes.
So how does ZK actually address these points?
Well, think about it. ZK proofs act as these cryptographic guarantees.
Okay.
They let us verify the integrity of data and computation.
Without having to trust any single entity.
Right, which is huge for decentralized systems.
Can you give me an example?
Sure, imagine a decentralized Oracle network where all the data feeds are verified using ZK proofs.
So you're cutting out the middleman, the single Oracle provider.
Exactly. The system becomes more robust, more secure, and truly decentralized.
That's really cool. So it's not just about efficiency. It's about building a new foundation of trust.
From the ground up, based on mathematical proofs.
What, are there any challenges to this? I mean, is it all smooth sailing from here?
Well, no technology is without its challenges.
Right.
And one of the main hurdles for ZK has been the complexity of actually building with it.
Like it's been really difficult for developers.
Historically, yes, it required specialized knowledge and tools.
But innovations like Succinct's sp1 are changing that, right?
Absolutely. They're making ZK development much more accessible.
By letting developers write in languages they're already familiar with.
Like Rust. Yeah.
So that whole write in Rust and let the ZK magic happen thing is actually becoming a reality.
It's getting there.
That's awesome.
Yeah.
But what about other challenges? Like, isn't generating these proofs super computationally intensive?
Yeah, that's another big one. Performance is key.
So we need more efficient proving systems and hardware.
Definitely. That's where a lot of the research is focused right now.
Makes sense. So it's a two-pronged effort.
Yeah.
Make ZK easier to use and make it faster.
And don't forget about education. A lot of people still don't even know what ZK is.
True. We need to spread the word and demystify the tech.
That's part of what we're doing here, right?
Exactly. We're all about exploring these groundbreaking technologies and their impact.
So everyone can be a part of the conversation.
Now, Roy mentioned this really interesting concept of ZK identity.
Oh, yeah, that's a big one.
Can you expand on that a bit? What would a world powered by ZK identity actually look like?
Imagine a world where you control your own data.
Okay.
And you can choose exactly what information to reveal.
So like proving your age without giving away your birth date.
Exactly. Or verifying your credentials without sharing your entire educational history.
That would be amazing. So much more privacy and control.
Right. ZK identity could completely revolutionize how we manage and protect our online information.
That's a really powerful idea. So it's not just about verifying computations, it's about verifying ourselves.
In a way, yeah, it's about creating a more trustworthy and secure digital identity layer.
So what are some other exciting use cases that Roy mentioned? Besides ZK rollups and identity, of course.
Well, let's see. They talked about verifiable voting systems.
Oh, wow. Like elections that are actually fair and tamper-proof?
Exactly. And then there's supply chain transparency.
Using ZK proofs to track the origin of goods.
Yep. Combating counterfeiting and ensuring ethical sourcing.
That's huge. What else?
Even decentralized social media could benefit from ZK.
Like being able to verify the authenticity of content.
Exactly. And users would have more control over their data sharing.
The possibilities are really mind-blowing.
It seems like ZK could touch almost every aspect of our digital lives.
Okay, so let's say I'm a developer and I'm totally sold on this whole ZK thing.
Awesome. Welcome to the club.
Where do I even begin? What resources or tools should I check out?
Well, Succincts sp1 is a great starting point.
Okay.
It's designed to be developer-friendly. You can jump right in.
And what about other ZK libraries or frameworks?
Oh, there are tons. Circum, Socrates, Halo 2, they're all great.
So there's a whole ecosystem ready to support new ZK developers.
Absolutely. And the ZK community is super active and welcoming.
Like online forums and stuff?
Yep, and chat groups, even online courses.
So it's easy to find help and connect with other people?
Definitely. The more people working on ZK, the better.
It's really inspiring to see this technology evolving so rapidly.
It's amazing how far we've come in such a short time.
It feels like we're on the verge of a whole new era for the internet, built on verifiable trust.
It's an exciting time to be involved in this space.
But with all this talk about ZK proofs being these cryptographic guarantees, can they be broken? Like, is there any way to cheat the system?
That's a great question, and one that researchers are always investigating.
So there's no easy answer.
The security of ZK proofs relies on some pretty complex math.
Okay.
And the strength of the cryptographic algorithms used.
So it's not like someone can just hack into a proof and change the outcome?
No, forging a ZK proof is theoretically possible, but it would require an insane amount of computing power.
And time, probably.
Yeah, it's basically infeasible with current technology.
So it's not a practical concern right now?
Not really, but researchers are always looking for potential weaknesses.
Just in case. Yeah.
Exactly. It's always better to be prepared.
So it's not that the fundamental ideas behind ZK are flawed.
No, the math is solid.
It's more about making sure specific implementations are secure.
Right, and constantly improving those implementations as new attacks emerge.
It sounds like we're entering a whole new era of digital trust.
Where cryptography and math are the foundation.
That's pretty cool. But before we get too ahead of ourselves, I think we need a moment to digest all this ZK goodness.
Take a breather, let it all sink in.
We'll be back shortly to discuss how this tech could reshape everything.
From how we vote to how we manage our digital identities.
Don't go anywhere. And we're back for the grand finale of our ZK deep dive.
It's been quite a journey. It really has.
You know what strikes me? It's how ZK kind of flips the script on how we think about trust.
How so? Well, traditionally, we've always relied on these big institutions, right?
Yeah. Banks, governments.
To guarantee information is valid, systems are working properly.
Like we trust banks to manage our money?
Governments to issue our IDs.
Social media companies to keep our data safe.
But that creates these single points of failure, right?
Totally, and potential for abuse, too.
It's a trust me system, and sometimes that trust is broken.
Exactly, but ZK offers a whole different approach.
Instead of blind trust,
we can have these cryptographic proofs, mathematically verifiable by anyone.
It's like saying, here's the proof, see for yourself.
No more trust me, it's trust the math.
Exactly. And that shift has the potential to revolutionize how we design and interact with everything online.
Leading to a more transparent, accountable digital world.
Where trust is built on solid foundations.
I really like that phrase Roy used, harnessing humanity's collective intelligence.
Oh, yeah. That's a good one.
It seems like ZK, especially with this prover network idea.
Yeah. Enables this new kind of collaborative computation.
Like, instead of relying on a few centralized entities to do all the heavy lifting,
we can distribute the work across a decentralized network.
Everyone contributes their computing power, earning rewards.
Creating this global brain that crunches numbers and generates proofs for everyone's benefit.
And because those proofs are publicly verifiable,
we don't have to trust any single prover.
Or even the entity that designed the system in the first place.
We trust the math, the foundation of ZK itself.
Which opens up so many possibilities for building systems that are more resilient, transparent,
resistant to manipulation, censorship, all the bad stuff.
We could have decentralized, trustless versions of systems that we currently rely on central authorities for.
It's mind-blowing when you think about it.
ZK lays the groundwork for a whole new paradigm of digital trust.
One that could transform industries, societal structures, everything.
So it's not just about technology, it's about how we organize ourselves as a society.
It's about shifting power dynamics, making things more equitable.
What if we could verify the fairness of elections without relying on any single authority?
What if supply chains were truly transparent? No more shady dealings.
What if we could actually know if the content we see online is authentic?
These are the questions ZK forces us to ask.
And the possibilities are truly endless.
I think we're just scratching the surface of what we can achieve with this tech.
It feels like we're standing at the edge of a new frontier.
A new era for the internet, where trust is baked in from the ground up.
As we wrap up this deep dive, I'm just in awe of the ingenuity behind zero-knowledge cryptography.
It's truly remarkable, the elegance of the math, the potential for positive change.
It's a reminder that we have the tools to build a better digital future.
A more secure, more equitable future for everyone.
So to our listener, we leave you with this final thought. If ZK can bring verifiability to any computation, what other aspects of our digital lives could be transformed by this technology? What problems could we solve? What opportunities could we unlock? Let those questions be your guide as you continue to explore the fascinating world of zero knowledge.
And keep asking questions, keep pushing the boundaries. The future is waiting to be built.
Thanks for joining us on this incredible journey. Until next time, keep diving deep.